girls, welcome to video lesson 9-6, our lesson on the polar coordinate system. The polar coordinate system deals with an ordered pair just like we do with the rectangular coordinate system. But as opposed to going to x comma y, we are going to go r comma theta, where r is the distance from the origin and theta is the angle, where we're starting at due east is our 0 degrees. So if I have the ordered pair 2 comma 60, I'm going to have an angle of 60 and a radius of 2, so that ordered pair is right there. If I have the ordered pair 4 comma pi over 4, my angle is pi over 4, which of course is 45, and I have a radius of 4, so that point would be right there. Just be careful because we can name these points a lot of different ways too. I could also name, this ordered pair right here, 4 comma pi over 4 as also negative 4 from the angle of that would be 5 pi over 4. So this angle here, this point right here, could also be written as negative 4 comma 5 pi over 4. This point right here could also be, if we wanted to, it could be angle negative 300 with a radius of 2, so that could also be 2 comma negative 300. In fact, there's an infinite number of ordered pairs that we could name for each polar coordinate. Polar and rectangular conversions. X is always equal to r cosine theta, and that makes sense if you think about the x. If this is my ordered pair, this distance right here is always going to be x is equal to r cosine theta. So x is equal to r cosine theta. And y, this distance right here, y is equal to r sine theta. Okay, r squared will always equal x squared plus y squared. We get that just using the Pythagorean theorem. And tan theta will always be y over x, and that makes sense too. If this is my theta right here, then tan theta is y opposite over the adjacent x. Okay, don't forget about our Pythagorean theorem, our Pythagorean identities. Sine squared plus cosine squared is equal to 1. So let's convert these. I would always probably, if I wanted to, think about what this picture looks like. Oh, that's straight up and down. That's straight across. If I have the ordered pair 3 comma pi over 2, that's pi over 2, which is 90 with a radius of 3. So that ordered pair in rectangular coordinates is 0 comma 3. Okay, we can find that by also saying, x is equal to 3 cosine theta. Well, cosine of 90 is 0, and y is equal to 3 sine theta. And of course, sine of pi over 2, 90 is 1, so y equals 3. If I have the ordered pair, let's change colors. Let's change colors to red. Negative 2 comma 11 pi over 6. 11 pi over 6, of course, is 210. No, it's not. It's 330. So we're going to go to 330 with a distance, so we have an angle of 330, which is all the way around to here, but we have a radius of negative 2, so we're going to go back to here. Okay? If I think about what that point looks like in terms of rectangular, if I think about this triangle right here, this angle is 30, this distance is 2, so therefore this is 1, and this is negative root 3. So this ordered pair in rectangular is going to be negative root 3 comma 1. Okay, and we can find that by using our conversions as 2. x is going to equal r cosine theta. So that's going to be -2 times cosine of 330, which does turn out to be negative root 3, and y is equal to -2 sine of 330, and that of course equals +1. If I want to think about going the other way now, if I want to think about going from xy coordinates to rectangular coordinates, first thing I want to do is probably plot this point. I got in 1 comma root 3, which is right about there. Okay. Of course, we can look right now. This is 1. This is root 3. So this length would be 2. So we already know that this ordered pair is 2 comma. That would be an angle of 60. Okay. But if not, we can always use our conversions by saying. Okay, we're going to use our conversions by saying tan theta equals y over x. So tan theta is equal to y is, don't tell me, root 3. X is 1, and what angle has a theta of, or a tangent of root 3? That's 60. So our angle is 60. So we go over here and put a 60 right here. And also now don't forget that x squared plus y squared is equal to r squared. So x squared plus y squared is equal to r squared. So therefore, 1 squared plus root 3 squared is equal to r squared. R squared would equal 4. So r is 2. And there is our ordered pair in polar coordinates. Looking at 7 comma 0, I'm just going to erase real quick here. 7 comma 0 would have a radius of 7 and an angle of 0. So there is our ordered pair. Without doing much work here, let's just write that in polar coordinates. That's going to be an r of 7 and a theta of 0. And so, once again, as we look there, the polar coordinates are also 7 comma 0. When we're converting the equations from rectangular to polar, I think that's a little bit easier. We're going to replace x and y with the polar coordinates, meaning we're going to replace x with r, or we're going to replace x with r cosine theta, and we're going to replace y with r sine theta, and then we're going to solve for r. Going from polar to rectangular sometimes can be a little bit harder. When I say use conversions right here, I'm talking about saying, okay, x is equal to r cosine theta, y is equal to r sine theta, x squared plus y squared is equal to r squared, and don't forget that y over x is equal to tan theta. So, if we want to convert x squared plus y squared is equal to 16 into polar coordinates, we're going to do that by saying, okay, x squared is x. First of all, let's think about this. X squared plus y squared is a circle with a radius of 4. Okay, but we can do this so we can convert this rectangularly by saying x squared, which is r cosine theta squared. So it's r squared cos squared theta plus, erase this, r squared sine squared theta is equal to 16. We're going to factor out the r squared, so I have r squared is equal to cosine, r squared times cosine squared plus sine squared is equal to 16. Well, this, of course, is just uno. R squared is equal to 16, so therefore r is equal to 4. So as we think about our polar equation, r equals 4, there is no theta we need to worry about, but we can see now that, sure enough, that is a circle with a radius of 4. We look at this one right here, y is equal to x. I'm going to take this y equals x and divide both sides by x. And again, we can think about, first of all, let's just think about what this graph looks like. Y equals x is that line right there. I now have y over x is equal to 1. Well, y over x is tan theta. Tan theta is equal to 1. Well, what angle has a tangent of 1? Theta is equal to 45 degrees, and sure enough, this angle right here is 45 degrees. So there is our equation. Either tan theta is equal to 1, or we can write theta is equal to 45. As I look at this one right here, I'm going to replace x and y with r cosine theta and r sine theta. So I have 4 times r cosine theta plus 7 times r sine theta is equal to 2. I'm going to factor out my r. So r times 4 cosine theta plus 7 sine theta is equal to 2. And then just divide both sides. To solve this for r, divide both sides by 4 cos theta plus 7 sine theta. Okay, and I'm not going to write it out here on this side, but divide that side. So basically, when I'm done here, r is equal to 2 divided by 4 cos theta plus 7 sine theta. And, you know, if you graph that on the graphing calculator in your polar coordinate system, you will get a line. And this, of course, we know is a linear equation. Okay, this equation right here is going to be a hyperbola. But let's write this in polar coordinate, in the polar equation. So this is going to be 2x is r cosine theta times y, which is r sine theta, is equal to 1. I'm going to factor out or pull out the r from both of these factors. So I have r squared times 2 cos theta sine theta is equal to 1. I'm hoping you recognize that 2 cosine sine is r squared times sine 2 theta equals 1. I'm going to solve this for r. I'm going to divide both sides by sine 2 theta. So now r squared is equal to 1 over 2 sine theta, which we can leave like that. We can also say that this is now equal to 1 half sine, I'm sorry, I wrote that wrong, didn't I? Sorry, sine 2 theta, not 2 sine theta. Big difference, okay? So we can also say that that's equal to cosecant 2 theta. And technically speaking, if we want to solve for r, we're going to take the square root of both sides. So r is equal to plus or minus cosecant, the square root of cosecant 2 theta. Okay, going from polar coordinates to rectangular equations, I think is much harder because we don't recognize what these things are just by looking at them the way we can sometimes with the rectangular coordinates. But as I look at this equation right here, I'm going to multiply both sides by r. So I'm going to get r squared is equal to r 2 cos theta. Okay. R squared, of course, is x squared plus y squared. And 2 cos theta is another way of saying 2r cos theta. And r cos theta, of course, is x. So I have x squared plus y squared is equal to 2x. I now can subtract the 2x from both sides. So I have x squared plus y squared plus 2x is equal to 0. And if you graph that with I'm hoping you recognize that as a circle. And if you graph this original equation on your calculator, you would get the same circle. R equals 10, well, that's kind of an easy one. We can hopefully, you guys recognize this thing as a circle with radius 10. Okay, but again, we can do this algebraically by squaring both sides. So we get r squared is equal to 100. Now we just replace the r squared with x squared plus y squared is equal to 100. and we recognize that as a circle with a radius 10. Fantastique. And lastly, we have theta equals 5 pi over 3. Just think about what that looks like. This would be a line with an angle of 5 pi over 3, and 5 pi over 3 is 120, I believe, right? So that's going to be that line, because this angle is 5 pi over 3. Okay? But again, we can do this algebraically by saying theta is equal to 5 pi over 3, and I know that tan theta, I'm going to take the tan of both sides, so tan theta is equal to tan 5 pi over 3. Well, tan theta is y over x. Tan of 5 pi over 3 is, don't tell me, I think it's going to be negative 1 over root 3. That's wrong. It's negative root 3 over 1. My line wasn't drawn correctly. So now I'm just going to multiply both sides by x, so I get y is equal to negative root 3x. And there is my equation in rectangular form.